Hello everyone and welcome to the OneSolve YouTube channel, and for today's Make It Snappy session, the Inventor feature that I'm going to showcase today will be the Thread tool. So the Thread tool is really nice because it allows you to attach thread information to your components, specifically for thread profiles for bolts, nuts, holes, etc. And the thread tool can be used very quickly. How this works is, you'll notice I do have some form of a model of a bolt, and I'd like to apply some thread to the actual stub itself. To fire off the Inventor Thread tool, all I have to do is simply head over to my ribbon and start the thread function. Once that's been done, the dialog box will appear, and the first thing it's going to ask me to do is select a surface. So ideally this is going to be a cylindrical surface, and I can head over to my model and choose where I'd like to place my thread. So before I choose it, there's something I'd like to cover first off, is the start point of your thread is determined by whether you place your cursor at the top or bottom of your feature. Okay, so for example, if I head over to the top of my bolt near the head and select over there, my thread begins at that point. You can see there's a arrow indicating the start position as well as the direction of your thread profile. Alternatively, if I close that down and clear the selection, I'll head over to the bottom of the bolt and select that portion of the cylinder, and now my thread profile begins at the bottom. So depending on where you select or choose to apply your thread onto your cylinder will determine where your thread profile starts. Okay, just to do that once more, I'm going to select the top of the bolt portion and my thread profile begins over there. So once I do that, a image preview of the thread will appear, and then I can make some adjustments. So the next step in using the thread tool is assigning the associated metadata to the thread itself. So this is going to determine what type of thread it is, the size, the designation, will it be left-handed or right-handed. This can simply be done directly through your dialog box, where you can cipher through all your standard thread profiles or types. In this case, I'll select ISO, and for the size, it picks up by default the size of the feature. Okay, so this stub is actually 15 millimeters in diameter, so I do not need to change that size at all. We can then change the designation of the thread, diameter 15, or the thread size, okay, 1.5 or 1 millimeter. Alternatively to that, you can change the class or define whether your thread is going to be left-handed or right-handed. Just below the thread information, we have the behavior. This will determine the distance, or how far is your thread going to travel. So we can toggle a manual depth. Okay, for example, I can type in 70, and the thread profile will increase from the top to the bottom and be a distance of 70 millimeters. Alternatively, if you want your thread profile to take up your entire feature that you've chosen, you can simply toggle this button to turn a full depth on. Once that's done, it takes up the entire feature. So from the start position to the end, we have a thread profile that's been created. Now what I'm going to do is toggle that off and apply a depth of 60 millimeters from the start to the bottom. So when you have the manual input option to define the depth toggled on, you can also apply an offset. So this will allow you to change the position of your thread. So for example, for this bolt, I'd like to have a grip distance. So I'd like to shift my thread profile down a little bit from its start position. I can simply head over to the dialog box, type in a distance of 20 millimeters, and my entire thread profile itself will shift. Okay, once I'm satisfied with my inputs, I can simply confirm that in the dialog box, and what you'll notice is a thread image has been applied over my part. So the thread image does not actually make any physical thread cutouts into your feature. These thread profiles are very insignificant in terms of how they impact the weight or size or mass of your model properties. So in this case, what we're actually trying to get from the thread tool is the metadata. Okay, what type of thread is being used, what's the pitch of the thread, is it going to be left-handed or right-handed? And this comes in use later or downstream in terms of the 2D drawing documents that you'll create for this component. So once your thread has been applied, where it's ideally being used is within the drawing environment. So what I'm going to do is head over to drawing and quickly apply a hole in thread node. Okay, because this component has a thread feature that's been assigned to it in the modeling environment, when I document it very quickly with a leader, it pulls through the associated thread information that has been initially assigned. Okay, fantastic. That pretty much summarizes how you use the thread tool inside of Inventor. Hope you enjoyed this session. Stay tuned to our Inventor Make It Snappy series for more content.